Hello everyone. Today we're going to talk about two of my favorite subjects, which are science and of course music. Did you know that music is science? It is, because music, as we all know, is sound, and sound is science. So we're going to talk about how sound works and how those sound waves become music to our ears. Okay. First of all, sound is created by vibration. When an object moves very quickly, that's called vibration. So it's created by movement. I have some rubber bands here, and if you pluck the rubber band, you can hear it. It makes a sound. But when you stretch it over an object, for example, I have a shoebox here, but really you could use anything, an empty coffee can, a plastic storage container, even a tin can like you would have food in, a food can. If you stretch it across, the object that you're stretching across has to be hollow, and there's air in there. So what happens is when I pluck the rubber band, it vibrates and it creates sound waves, and those sound waves bounce around against the shoebox and it comes out louder. That's called resonance. My students who have played xylophones before, we've talked about this because the xylophone bars are on a box, right? And I've talked about how that box part of the instrument is really important because that's how the sound gets louder. When you strike a xylophone bar, the sound waves go inside the box of the xylophone, they bounce around, it's hollow, and when it comes out, it's louder. So we can do the same thing with a rubber band. When I hold it over the box, it's louder than when I just plucked it in the air. You can change the pitch. When I pull it tighter, it's going to vibrate faster. That's called frequency. The higher the frequency, the higher the pitch. Now remember, pitch and volume are not the same thing. So when I talk about a higher frequency or a higher pitch, it's not the same thing as being louder. This is high, this is low. So it has nothing to do with loud and quiet. So frequency, this is going to vibrate faster and it's going to make a higher pitch. Listen. So the tighter you stretch it, the faster it vibrates and the higher the pitch. And if I loosen it, make it really loose, then you can almost see the vibrations. It happens slower so that your eyes can catch it. And it also makes a lower pitch, lower frequency. It vibrates fewer times per second. Frequency, again, is the number of times an object vibrates per second. So that's lower. So you can experiment with this at home if you have some kind of container that's hollow. Like I said, a plastic storage container, an empty coffee can or whatever. Stretch a few rubber bands across and see how different rubber bands can make different pitches. How can you make them vibrate faster and slower? So maybe I'll pull this one tighter and let the other one be looser. And now I have two notes. And you can experiment with lots of different rubber bands and different tension, how tight they are on the box. Now, I have some mason jars here with different amounts of water in them. This one is almost full of water. This one's probably about 3/4 full, and this one is empty. Now when I hit these jars with a wooden spoon or a metal spoon or something, they're going to make different sounds depending on how much water is in them. I'm going to put some food coloring in the jars that have water so that you can see it a little bit better. Plus it's pretty. Put a couple drops of blue in the one with the most water. Let's go with a drop of pink for the one that has a little less water. And then I'm not going to put any food coloring in the empty one. See, I'm going to stir this around a little bit so you can really see the color. That's pretty. Now, I'm going to start with my wooden spoon. Do you hear that sound? Wow, isn't that cool? This one that's empty has the most airspace and it makes the highest pitch. So that means the sound waves are vibrating faster. The frequency is higher. This one, the water slows it down a little bit. And slower means it has a lower frequency and a lower pitch. And then this one, with more water, the water slows it down even more. And so it has a even lower frequency and a lower pitch. So let's see. I just played hot cross buns using water in mason jars. How cool is that? You can experiment, boys and girls, at home using different amounts of water. You don't have to do the same amount that I've used. You can change it up and see what different notes you can make with more jars or less jars and different amounts of water. Let's try another song. How about Mary Had a Little Lamb? And when you're experimenting, try tapping the jars with a different object. So instead of a wooden spoon, let's try a metal spoon and see which sound we like better. So that is a fun thing to do at home. Just put water in some glasses or jars and see what sounds you can make with that. That is so much fun. Now I have another experiment here. We're going to make oobleck. That is such a funny name, isn't it? What oobleck is an equal part of cornstarch and water. And again, cornstarch you can just find in the baking aisle at any grocery store. It's a very common ingredient. When you mix equal parts of cornstarch and water, it makes what's called a non-Newtonian fluid. What that means is it has the properties of a solid when you apply force to it. Like if I smack it, that's force, and it's like a solid. Like this is a solid object. It doesn't move when I touch it. Liquid, it has the properties of a liquid when you don't apply force. So if I take a finger and just gently touch it, it's like a liquid. So it's amazing. It's really cool to touch it. So if you get a chance to make this at home, try it. It's really cool. So why am I making oobleck, and how does that have to do with music? Well, did you know sound waves on the oobleck can act like force? So it jumps and dances around. Unfortunately, the speakers that I usually use for this experiment are at school. I don't have them here at home. What you need are the type of speakers, the old-fashioned kind, where you can take off the cover and then it kind of goes down in a circle. So and then you cover that circle because you don't want to put oobleck on top of the speaker. That would be bad for it. But you cover it with a plastic of some kind, and then you put the oobleck on it, and when you turn on some music with a really low frequency, low pitch music, the oobleck will dance. And I have a video of this that I did last year, and I will put that at the end of this video so that you can see it. But to make oobleck, again, I have a half cup of cornstarch in here, and I'm just going to add a half of a cup of water, and then I'm going to stir it together. So that's all it is very simple. You just mix the cornstarch and water and stir them together. And this stuff is so much fun to play with and experiment with. Okay, now I actually need to add a little bit more cornstarch. It's a little too thin. So I'm going to go get some more cornstarch. Okay, so now it's perfect. I'm going to smack it, and it really is like a solid. I don't know if you can see that really well. Let's see. It's like a solid, but when I touch it with one finger and just slowly put it in, it's a liquid. This stuff is super cool. So again, it's called a non-Newtonian fluid because it has the properties of a solid when you apply force and a liquid without force. It's really cool stuff. And parents, don't worry, it cleans up very easily. It's just cornstarch. So if I get it on my clothes, which I have, it's on my pants. If you get it on your clothes, it's okay. It washes right out. So at the end of this video, I'm going to put a video of some dancing oobleck on a speaker that I've done in the past. Thank you for watching, and I hope you have a great day.